The way we've written this, the x values are our angles, the y values are the numbers that we get out. Yes? So we're just going to start this with a good old XY chart. And normally when we make XY charts, we just pick like 0, 1, 2, 3, 4, right? That doesn't really make sense here because I need to pick angles here. So if I said pick 1 and I asked you what the sign of 1 is, you don't really know what that is, right? So let's pick angles from our unit circle. Could we start with 0? Right, I don't want 0.017. I want to pick angles that we know. Like 0. What would the sign of 0 be? I'm going to write this over here. Like, remember back in like Algebra 1, did you ever do this where you like wrote like y equals sign of x? So you could say y equals sign of 0. Well, I know, but when you first did like lines, like maybe you put that in the middle and you put the y value. But what is the sign of 0? 0. Skip some space here. We'll come back, okay? So leave some space. But what if I picked like nice points, like pi halves? Ooh, that's a good one. What is the sign of pi halves? Sign is y. At pi halves, the y coordinate is 1. When we have a test, you're going to have a no calculator part of your test again, which means you still got to know these. Can we pick a number between 0 and pi halves?
Pi thirds.
We could pick pi thirds, we could pick pi fourths, we could pick pi sixths. All of them would be good choices. We could pick all of them if you want, but I don't really want to pick 8,000 points. So what do you want to do? Pi fourths is halfway in between. It's going to be a square root, but that's okay. We could graph decimal. We could pick pi sixths or pi thirds. You have a choice. Anybody care? I like symmetric things, so if nobody wants to say, I'm going to pick pi fourths. What is the sign of pi fourths? Square root 2 over 2. That's not going to be very fun to graph. So maybe we should type that in our calculator and see what it is. Maybe like 1.707 or 0.707, not 1 point. So it's like 0.7. We're going to just say that. What else could we pick? What if we picked pi? Skip a space. Pick pi. I won't have to pick all these points every time. I'm trying to get this general shape here, kids. The sign of pi is 0. Should we pick a point in between pi halves and pi? Oh yeah, maybe let's pick 3 pi fourths. What's the sign? Because it's halfway in between. It's nice and evenly spaced. Square root 2 over 2 again, which is 0.7. Only halfway around the circle. I think that means we got to pick a lot more points. Let's go from pi. What would be the next point? 3 pi halves. And the sign of 3 pi halves is -1, you mean? And probably we should pick the one in between, right? Halfway between pi and 3 pi halves is 5 pi fourths, which is still my square root 2 over 2, but now I'm negative. You with me on that? You see how I'm just going around the circle? So it's -0.7?
Pretty much a circle.
It's not a circle, because we're graphing it on a line. We're graphing it on a coordinate plane. Like, we're taking the unit circle and we're, like, unfolding it and putting it on an xy plane. It's not going to be a straight line. I agree with you. But let's see. We're almost back around. 2 pi. What's the sign of 2 pi? 0. You don't have that lovely extend page like I do. And halfway in between that would be 7 pi fourths, which I think is also negative square root 2 over 2, which is -0.7. No, you don't always have to do these many. We're trying to make a point here.
Making a lot of points.
A lot of points. Here, we've talked about the period of sine and cosine. To get all the way, to get all the values, you have to go from 0 to 2 pi, which means the great thing is, boy, I'm taking these points every time, but do I ever need to pick numbers bigger than 2 pi? Because what's going to happen as I get numbers bigger than 2 pi? I'm just going to repeat the same values. We call it a periodic function. all wrote on your test. It repeats itself. All right, so let's graph. We want to try to evenly space this, okay? We want to make as nice lines as we can. So make a line on here, and you're going to make that your 2 pi. And then let's go like halfway in between, and that would be pi. And let's go like halfway in between that, and that would be pi halves. And halfway in between that would be 3 pi halves. And I'm not going to make my pi fourths, but do you agree all the fourths are going to be halfway in between each one of these? Yes? So halfway between 0 and pi halves is pi fourths. 3 pi fourths, 5 pi fourths, 7 pi fourths. It's not. The y values, what's the biggest y value I ever get on this? What's the smallest y value? So there's no need to make like 20 marks on your y-axis, right? I'm going to make a nice graph, so I'm going to make it very spaced out. Like I'm going to make the line way up here, and I'm going to label that 1. And I'm going to go down here and make a line pretty far away and label that -1. When you graph trig functions, it's really important that you label your axis. Because if you don't label it, I read it as going by 1s. And the x-axis is definitely not going by 1s, so you have to label something so that I can see what it's going by. Also, we always label in equal increments. Like, you can't just label, like, pi, and then 3 pi halves, and, right? Like, you can't jump. Like, it needs to be equally spaced. You want to make nice graphs. So let's graph our points. 0, 0. Grady said he did that one already. At pi fourths, it's like 0.7. So, you know, that one's kind of not so fun to graph, but I'm going to say 0.7 is about right there. That's 0.8. At pi halves, I'm going to go up here and graph 1. And then in quadrant 2, between pi halves and pi, it's still at 0.7. That's square root of 2 over 2. And then at pi, it goes back to 0. That's a little off, but that's okay. So we're going to graph up here. And then at 5 pi fourths, now we're down in quadrant 3. So now we're down at like -0.7. Or like -0.86. At 3 pi halves, we get our lowest value, which is -1. Then we go back to negative square root 2 over 2, and we end back where we started at 0. If we connect this with nice, smooth edges, no sharp corners, this is going to look very smooth like this. It's going to go up, and down, and back up. Oh, kind of parabolish, right? And here's what's really cool. You don't have to keep going here, but this is just going to repeat, which means what's going to happen next? I know when it gets bigger than 2 pi, it's going to go back up again. This should be better more like this. It's going to go back up, and then it's going to go back down, and then it's going to go back up, and it's going to go back down. And it's just going to repeat that same pattern forever because it's a periodic function. You're just going around the circle again and again and again. Does that make sense? You don't have to make all that nonsense. But we do need to fill out the back side of our graph. So if we're on this side, what kind of angles do I have over here? Negative angles. So I'm going to graph the same numbers, only negative. So I'm going to graph -2 pi. I'm going to go -pi. And how I normally do it is I just go in between. Like I label every other one. So then you can see that I'm going by pi halves. But you can label it all if you want. So we can think about this, but then we're going to make a little comment, so we have to do it every time. 2 ways to think about this. One is we can actually find the values and figure them out. So like at -pi halves, where's -pi halves really at? -pi halves is the same as 3 pi halves. So is it going to be the same as what I got at 3 pi halves? Negative, aka -pi halves equals 3 pi halves, which is just going to equal -1. So that's just going to go back to -1. I kind of skipped the 0.7s. And at -pi, is -pi the same as +pi? Which means it's just going to go back to 0. What else is really another way to do this? If this is going to repeat itself over and over again, if this side just came from up, do you agree that it makes sense that this side has to go down if we're repeating this pattern? So that's another nice way to do it. So that means that this side's going down. What's going to happen at negative 3 pi halves? Where's that going to go? Up to 1. And then negative 2 pi is the same as positive 2 pi, back to 0. And now that I know the shape is this lovely smooth curve, you don't really necessarily have to graph the decimals in between. I can just make my lovely graph like this. Really nice thing to point out about this function is sine is an odd function. Remember we talked about even and odd functions? Odd functions means that when you plug in a negative, you get the opposite from when you plug in a positive, which is why the negative side is the exact opposite as the positive side. The domain of this, you can pick whatever you want for x. We just pick nice angles. But the domain of this is negative infinity to infinity. The range of this is what? Negative 1 to 1. Just like we know what y equals x squared is, and we can do transformations with that, and we know all those graphs, x cubed and the absolute value graph, absolute value and all that stuff, that then we can stretch and shrink and slide to the left and the right and all that stuff. It's the same thing with this. That's why I spend so much time graphing this the first time. You don't have to pick a million points every time. I call them key points. Pick the points that give you zeros, ones, and negative ones, which for the most part means we pick the ones that go around the unit circle on the axis, right? So like normally when I do this, I'm only going to pick 5 points. I'm going to pick 0, pi halves, pi, 3 pi halves, back to 2 pi, picking all those key points. What else should we do? Let's graph cosine. Thinking about the values that we get from the unit circle for sine and cosine, do you agree that cosine is going to look similar to sine? But it's going to be in different spots because cosine is 0 in different spots than sine is 0. Cosine equals 1 in different spots that sine equals 1. So instead of picking a million points here, let's just pick our key points. Why am I holding 2 markers? So excited. Oh, that would be exciting. Not today. We're spending all week on this, kids. Maybe Friday I'll give you that. So here are my key points. The whole period of cosine starts at 0, ends at 2 pi. Right? That's how long it takes to get back to where we started. So we're going to talk in a minute. Transformations can happen, which means the period can change. But right now, the period's 2 pi. We need 5 points. So we're going to take half of this. What's halfway between 0 and 2 pi? What's halfway between 0 and pi? Half pi, right? And halfway between pi and 2 pi is 3 pi halves. Do you notice on the unit circle, those are my x and y axes? Yes? Which means I should be able to do this without a calculator very easily. I should be able to get my y values. What is the cosine of 0? Cosine is x. So think about if I do my unit circle up here, that's the point 1, 0. Cosine is x, so it's 1. What is the cosine of pi halves? 0, because the x coordinate is 0. What's the cosine of pi? What's the cosine of 3 pi halves? Back to 0. What's the cosine of 2 pi? Back to where we started. Once you get back to where you started, because we know these are periodic, you don't have to ever pick any more points, because do you agree if we kept going around in the same increments, we're just going to get these same numbers over and over again. So we just got to get the basic thing down. So let's label our graph. We could pick all the pi fourths and all that stuff again if you want and get the 0.7s. But if we know the general shape is going to be this lovely curve, we can do this. Okay? So 2 pi, halfway between is pi, halfway, halfway. Right? That's kind of a nice way to make nice equal increments on your graph. Let's do the negative over here. Negative 2 pi, negative pi, halfway. What's the biggest y value I ever get? 1. What's the smallest y value I ever get? Negative 1. There's a big difference. At 0, sine is 0, so it starts at the origin. But on cosine, at 0, we get our biggest value. So at 0, the cosine of 0 is 1. Then it goes down to 0. And then at pi, it goes down to -1. And then it goes back to 0 at 3 pi halves. And then at 2 pi, it goes back here. So again, smooth curves, no sharp corners. What's going to happen after 2 pi? Should I make this going up? Never bigger than 1, which means you would make that going back down. And again, you don't have to do this part, but this is just going to repeat that same pattern over and over and over and over and over again. What happens on the negative side on this one? Again, if we're repeating the pattern, if you just look at the pattern, what makes sense that's going to happen after here? It should go down and end back up like this. And you can check that. If you did negative pi halves, that's the same as negative 3 pi halves, or sorry, positive 3 pi halves, which means you still just get 0 next. Negative pi is the same as positive pi, which means you get -1. Negative 3 pi halves is the same as pi halves, which gets you back to 0, and negative 2 pi gets you back to 1. So another big difference between sine and cosine is sine was opposite on either side of the y-axis because it was an odd function. Cosine is like our good buddy x squared. Cosine is an even function because whatever's on this side, it's exactly the same over here. Kind of looks like a wavy W, right? Domain and range are the same as sine. Domain is negative infinity to infinity. Range, -1 to 1. Always. Okay, so obviously I can't just give you sine and cosine to graph over and over again. So we want to talk about changing them, transformations, what happens. So I'm going to turn this. Everybody okay with that? So let's start. Oh, look, here's mine. Use key points to graph. Because I was trying to be cutesy and make noise, but it won't make noise now. See, look. It's supposed to make noise. Oh. Pick points that give you 0, 1, -1. Right? Without a calculator, you shouldn't be picking stuff like that gives you square root of 2 over 2. You should be picking points. This is not on your paper because I didn't want to waste a piece of paper to give you this, just one thing. But you know, you could write it somewhere else. Pick key points. It's Josh. I don't have to give you every slide. What if I gave you something with a 2 in front of cosine? Think about in terms of transformations. What does a number in front of it normally do to your graph? It stretches or shrinks it, which means think about when we pick our values here for cosine. I like to graph the cosine like in black behind here. So let's label our points first. Sorry, I'm getting ahead of myself. These are my go-to points. Maybe we should go to 2 on the y-axis this time. Just saying. I'm going to graph cosine like we just did. This is the parent function that you need to practice and get used to being able to graph very easily, of going through the unit circle and saying, at 0, cosine is 1. At pi halves, cosine is 0. It goes to -1, back to 0, back to 1. And it's exactly the same over here. And so this is kind of like my background function, so we can see the difference. This is my y equals cosine stance. same XY chart for 2 cosine x. Do you agree every value that I normally get, I'm just going to multiply by 2? So when I plug 0 in there, the cosine of 0 is 1. But now I have to take 1 times 2, which means now I'm going to get a y value of 2. You follow me on that? You do the cosine first, and then you multiply by 2. So what's going to happen at pi halves? What's the cosine of pi halves? 0. And what's 0 times 2? Still 0. At pi, the cosine of pi is negative 1. Negative 1 times 2. Negative 2. 3 pi halves. Am I still going to get 0? Still going to get 0. And at 2 pi, I still get 1, but 1 times 2 is 2. So that means you might not have to make an XY chart if there's just a number up front, because you're going to see, oh, all the numbers that were normally 1 and negative 1 are now going to be 2 and negative 2. So now I'm going to get the same shape, except I'm stretching it by a factor of 2. So here's the weird thing. In every other function we've ever talked about, we call these things a stretch or a shrink. In trig, we have special names for them. So you need to learn those because they're going to ask you stuff like that. So that's what the next slide is. Kind of a lot of stuff thrown at you, but we're really just talking about one letter right now. Okay? What time did we get out of here today? 55? Tomorrow, by the end of the day tomorrow, you're going to know what all these letters mean, which you probably could already figure out now because it's the same transformation stuff that we've always done. We're just calling them special things. But right now, if we're talking about just a number in front of sine or cosine, right now I just want to talk about a. And in the past, we've always just talked about that is a stretch or a shrink. If a is bigger than 1, it's a stretch. If a is between 0 and 1, it's a shrink, and it makes it kind of squish down. But basically, you're just multiplying all your values by that number. Notice that whatever that number is going to affect what our range is. Do you agree with that? Our range is no longer negative 1 to 1 if there's a number in front. Like the last problem that we just did, the range was negative 2 to 2. So a really does change a lot of stuff. So instead of calling this a stretch or a shrink, in trig, we call this the amplitude. And notice all of these, I'm talking about the absolute value of a. We'll talk about what a negative means for the problem in a minute. Amplitude is always positive. And the amplitude is just the number that's in front of sine or cosine multiplied in front of it. This is the definition of an amplitude. It's why it's absolute value, because it's distance. The amplitude is defined as half the distance between the maximum and the minimum values of the function. So think about the one we just did. It went to 2 to negative 2. So what's the distance between 2 and negative 2? 4. And what's half of 4? 2. Seems like a very complicated definition when they could just say it's a number multiplied in front of sine or cosine. But, you know, it's the math definition that they can say it's why it has to be positive. Sometimes you're going to have a question that just says state the amplitude and maybe state some other stuff. So you need to know that word. Amplitude is the number that's stretching or shrinking it. What's a negative in front of your graph going to do to it? What's a negative in front of x squared do to your graph? X squared normally points up, but if we throw a negative in front, it flips it over the x-axis, right? It's a reflection in the x-axis. A negative in front of sine or cosine means the exact same thing. So it means a reflection in the x-axis. So if they ask you to graph something with a negative, all of your numbers are going to switch. Normally sine starts at 0 and goes up, but if it's negative, it's going to start at 0 and go down. You can always make an XY chart to help you. The other important letter that we want to talk about today besides A is the amplitude. The other one we want to talk about is what if we multiply x by something, right? What if it's not just x? Well, then that means the period's going to change. Normally, it takes from 0 to 2 pi to get all the values for sine and cosine. But if there's a number multiplied in there in front of x, then it's going to change your period. And the formula for that is you're going to take the normal period, which is 2 pi, and you're going to divide that by b. And notice if b was 1, that's where you get the period of 2 pi. So these are the two big things for sine and cosine. So period, and let's just go ahead and rewrite this one again. Amplitude equals the absolute value of a, period equals 2 pi over b. And I want to graph one that has a different period before we leave here today, just to show you what that looks like. Okay, but 5 minutes, we have plenty of time. Period amplitude. Again, notice I have the regular graph because I want you to see the difference between sine of x and when I change the period here. So let's just talk about this one first. What is the amplitude of y equals sine of x over 2? What would be the a value in this? Nothing in front, which means there's a 1, which means my y values aren't going to change. But when there's something here with x, that means the period is no longer 2 pi. The period is now going to be whatever 2 pi over b is. Be careful on this. What is b in this problem? B's really 1/2, right? If b was 2, that would say sine of 2x. Yes? So it's a little tricky there. That's really like a 1/2 in front of it. So this is really 2 pi over 1/2. And what is 2 pi over 1/2? Multiply the 2 up. That means the period is 4 pi. Notice I have this really long graph here. That's because in order for us to get the entire sine graphed, we're going to have to go to 4 pi instead of 2 pi. So this is super important. Before you make your graph, you got to find how long the period is. This is also super important because it helps us pick really good points to graph. All right? So, are you right back there, Maddie? A period joke. Periods can be different lengths, right? Some are short, some are longer. I can make all the jokes too. Sometimes, well, here's a really thing. A period is like, we say how long it takes for the graph to complete one cycle, and it really creeps me out to talk about periods and cycles. And it's creepy. It's creepy to talk about. It's creepy. This period is 4 pi. Here we go. Okay, here is life-changing stuff about graphing. Because you might say, how do I know what to pick now? Every time. If you know your period, you're going to start at 0, you're going to end at your period. No, we're going to all giggle every time I say period, but that's okay.
Well, yeah, when you turn on period.
0 to 4 pi, right? Normally we do 0 to 2 pi because that's the normal length of the period. This is long. 4 pi. Sometimes the period's shorter. Half pi. You got to do fractions. That's harder. But this one's easy. What's halfway between 0 and 4 pi? What's halfway between 0 and 2 pi? What's halfway between 2 pi and 4 pi? These are my new key points. So whatever your period is, take half of it again, and you should always end up with those 5 awesome points that are going to give you your 0, 1s, and negative 1s. So we can work all these out, but you're going to see very quickly, oh, I already lost my equation. What was this? Sine of x over 2. When I plug 0 in here, that's still just going to be sine of 0, which is still just going to be 0. Yes? But watch what happens now because I taught you how to pick the awesome points. What happens when I plug pi in here? It's pi halves. And what is the sine of pi halves? 1. Right? So don't take the sine of pi. You have to plug pi into this problem. You follow me on this? So you're going to see we're going to get the same numbers. When I plug 2 pi in here, what's 2 pi over 2? That's really just the sine of pi, which is 0. Sine is y. 3 pi. Do not leave. Yeah, I'm holding you hostage. 3 pi is 3 pi halves, which is negative 1. And 0. I'm serious. We're not done.
Bradley Schrader.
So let's do 4 pi.
I sleep in the past period.
I don't care. You're staying
Taylor
there.
Strange, the office, please.
I don't care.
Can't see that I class was past.
I also need Chandler Hayden, the office, please. I just want to make a quick announcement that softball open gym has been canceled today. The next open gym will be this Friday after school.
So notice 0, 0. At pi, I plug 1 in. At 2 pi, I go back to 0. At 3 pi, I get -1. On 4 pi, I get 0. I will write you a pass to class. You'll be okay. Promise. So look what happens. We get the same shape, but it's stretched out over 4 pi. We still get that it goes up to 1, down to 0, down to -1, up to 4 pi. That is one complete period of sine. When it says graph 2 periods, you have to complete this whole cycle or you don't get all your points. Okay? So, the whole cycle.
Oh, man.
3 through 27, read the directions. You don't have to graph them all. Some of them just say, state the amplitude of the period, say how the graphs change. You don't have to graph them all. Goodbye. I'll send an email out, okay? Tell your teachers, check your email. My teacher is so mean and she keeps me after class.